You ever wonder how your email inbox just knows what's junk? Or how a shopping website can sift through thousands of customer reviews and tell you which ones are positive and which are negative, all in the blink of an eye? Well, today we're pulling back the curtain on that AI magic. We're going to get right into text classification and demystify how machines are learning to read, understand, and most importantly, organize our words.
So here's the game plan. We'll start with the big idea. What is this sorting machine, anyway? Then we'll look at the two main paths AI takes to get the job done. We'll meet the specialists and the all-rounders. And finally, we'll figure out how we can even tell if they're doing a good job in the first place.
All right, first things first, let's get on the same page about what we're actually talking about. What is text classification? At its core, it's the tech that's quietly working behind the scenes in so many things you use every day. Think of it as the silent librarian of the internet, making sense of the absolute avalanche of text we all create. The official term for all this is text classification, and really the definition is pretty simple. It's all about teaching a computer program, what we call a model, to look at a piece of text and automatically stick it into the right bucket. You know, buckets like spam, customer question, or 5-star review.
And this image right here, it nails the basic flow. You give some text to a language model, the model does its thing, it thinks about it, and then it spits out the category it belongs to. Text in, category out. Simple as that.
Okay, so we've got the what down. Now for the how. It turns out there's not just one way to build one of these sorting machines. There are actually two main philosophies, two different paths that AI takes to get this done. And the best way to think about it is the specialist versus the all-rounder. On one side, you have your specialists. These are representation models, and they're trained to do one thing and do it really, really well. And on the other side, you've got your all-rounders, the generative models. These are the jacks of all trades that can do pretty much anything, including classification, as long as you tell them exactly what to do.
Now here's the key difference. It's all about how they give you the answer. Check out the diagram. The specialist, the representation model, it just gives you a number, like 1, that stands for a category. But the all-rounder, the generative model, it actually writes out the answer in plain English, like the input class is returns. It's a subtle but really important distinction.
All right, let's zoom in on that first path. Let's talk about the specialists, or as they're officially known, representation models. Now these models, they don't start from scratch. Not at all. Think of it like they're standing on the shoulders of giants. They take a massive, powerful foundation model, like BERT, which already has a pretty deep understanding of human language, and then they're fine-tuned or specialized for one very specific job. And even within this specialist world, you've got a couple of flavors. You've got your task-specific model, which is kind of like buying a power tool that's already set up and ready to go for a common job. And then you have the embedding model, which is more like getting a whole toolkit. It gives you all the pieces you need to build your own custom solution. Now, this is a really cool detail. Before any of these AIs can read, they have to chop our language up into little pieces they can actually work with. These pieces are called tokens. You can see here how the word vocalization gets split into vocal and hashtagization. It's a clever trick that lets the model understand pretty much any word, even ones it's never seen before. Okay, and this is where embedding models do something that honestly feels a bit like a magic trick. It's called zero-shot classification. Get this, you can classify text into brand new categories without giving it a single labeled example. You just describe your categories in plain English, turn everything into numbers, and then just ask the computer, hey, which of my category descriptions is the most similar to this piece of text? It's an unbelievably powerful shortcut. All right, time to switch gears and look at that other path. The super flexible, super powerful all-rounders. We're talking about the generative models that you've definitely heard of, models like ChatGPT. With these models, everything, and I mean everything, comes down to the instructions you give them. The quality of your results is totally dependent on how well you write your prompt. You have to be super clear, super direct, just like the example on the screen, to guide the AI to the answer you're looking for. So the big takeaway here is that you're not using a specialized tool. You're just having a very, very specific conversation with a general-purpose AI. It's less about building a model from the ground up and more about becoming an expert at asking the right questions. You have to learn how to talk to it just right. So we have these two incredible approaches for sorting text. But once you've built one, how do you know if it's any good? How do you grade its homework? Well, it all starts with this chart, which has the slightly funny name of a confusion matrix. But don't let the name fool you, it's actually super simple. It's just a grid that shows you what the model got right and what it got wrong.
A true positive is when it correctly set a review as positive. A false positive is when it accidentally called a negative review positive. This grid gives us the raw data on its performance.
And from that simple grid, you can generate a full-on report card, which looks something like this. It might seem a little intimidating, but all it's doing is taking those raw numbers of rights and wrongs and calculating some more meaningful scores, giving us a much richer picture of how well our model is actually doing.
Let's break down the 4 big metrics on that report. Precision asks, of all the times the model shouted positive, how often was it actually right? Recall asks, of all the truly positive reviews out there, how many did our model manage to find? And this is so important because the choice matters. For a spam filter, you want crazy high precision, right? You'd rather one spam email get through than have a super important email get lost in the junk folder. But for, say, a medical diagnosis tool, you'd want sky-high recall. You want to find every single potential case, even if it means a few false alarms. Accuracy is just the overall grade, and the F1 score is a neat way to balance precision and recall into one number.
So, to wrap it all up, when do you use which one? Think of the specialist, the representation model, as your reliable workhorse. It's fantastic for high-volume, well-defined jobs where speed and efficiency are everything, like sorting support tickets. The all-rounder, the generative model, that's your creative problem solver. It shines when you need flexibility, maybe for analyzing open-ended survey answers to find themes you didn't even know to look for. It can be more expensive, but that adaptability is just incredibly powerful.
And this all leads us to one last really crucial thought. We've seen just how amazing this technology is at sorting our world. But as it gets better and better at putting everything and everyone into neat little boxes, it forces us to ask a very human question. Who gets to decide what the labels on those boxes are? Because the power to classify is the power to define. And that's something worth thinking about.